we are going to start with number 12. And if you're looking at number 12, it says to graph the function f of x equals x squared minus 2x minus 2. Then it gives you this little chart with x and f of x, and then it gives you the numbers it wants you to use, -1 through 3. So -1, 0, 1, 2, 3. Now remember, at the beginning of class on Monday, what would we have done? We would have, before we learned how to use our table function in our calculator, what would we have had to do for each one of these numbers? We would have taken this x, come up to this function, and everywhere we saw an x, we would have plugged in that number, which would be -1. And we would have had to do it here, 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 and here, right? But now that we know how to use the table function in our calculator, we no longer have to do that work, right? We just go to our y equals, because that's what f of x and y mean the same thing, and put in that into the y equals. So hit your y equals button, turn it on, then hit y equals. I still got stuff in there, so I'm going to clear it out. And type this into that y1. So I'm going to type in x squared minus 2x minus 2. So remember, your x button is the one that has that x and t and stuff on it. So there's your x. Now to hit squared, if you're doing squared, it has its own button. You can hit the x squared button. That'll put you a little exponent up there for the 2, and also bring you back down to where you're ready to type in minus 2x. It doesn't leave you up in the exponent. So I'm going to then type in minus 2x, then minus 2. Now, remember, in MathLab, when you are graphing, once you start to graph, before you can start plotting any points, what are you going to have to tell MathLab? You're going to have to tell it what kind of shape you're about to draw, right? Because that's the first thing it's going to tell you to do, is pick a tool, a graphing tool out of the palette. Okay? And there's all kinds of shapes over there. There's U's, there's V's, there's squiggle lines, and then there's regular lines. Okay? So what I want to do now is just hit my graph button so that you can see what kind of shape this makes. It made that U shape. Anytime your function, its highest exponent is a 2, it's going to make a U. Okay? So anytime it's x squared, it's going to make a U. But now, what do I need to know? I need to know what are the y's, because that's what this is y, that goes with each of these x's. That's what the table function tells you. How do you get to table? Do you see how table is written right above graph? And it's blue. Anytime you need to get to something that is blue on your calculator, you hit the second button, right? You hit the blue button. That tells me to go to the blue stuff. So second, and then graph again. There's that table. So all you have to do, what you have told your table, when you put in that y equals and you said x squared minus 2x minus 2, you've told it to, whenever x, if I plugged in -1 for these x's, what would it have given me? What does the -1x go with? I just put my cursor on it. What's the y that goes with it? 1, right? So it essentially fills out the graph for you. So what goes with 0? It looks like -2. 1 is -3. 2 is -2. And 3 is 1. Now, I am going to plot these points to show you the reasoning that instead of this making a line, it actually makes a U shape. That occurs because when this starts happening, you've got numbers though in the Y column that are the same. That means one side of your graph is starting to mirror the other side of your graph. That's what makes it be the U. Okay, so let's just plot these points So let's see. My first point is at negative 1, 1, right? Because that's what that table makes, is a bunch of points that are on this graph. So negative 1, 1. My x is negative 1, which means I'll go to the left 1. For my y, from there I'll go up 1. So there's where negative 1, 1 would be. What about this? 0, negative 2. If your x is 0, you start at the origin and you don't go left or right at all. And then the y is negative 2, so I'll go down 2. So far, I've only got 2 points. Any connecting of 2 points is going to make a line, right? That's why I need another point. I got to see what shape is going to happen here. So 1, negative 3. What does this mean to do? Go to the right 1, down 3. Starting in the middle, right 1, down 3. Right 2, down 2. Right 2, down 2. So there you can see the U happening. See these negative 2's that are the same? That's them right there. They have both done what? What does the y being negative 2 mean? You've gone down 2. I went down 2 in 2 different spots because of those y's that were the same. Okay? That's why the mirroring is occurring. My last point is at 3, 1. So over 3, up 1. So there's that last point. You connect them, you'll see that U shape. Okay? The next one, same kind of shape, right? I think it's negative x squared minus 7, if I remember right. Yeah, negative x squared minus 7. So, I'm going to go to my y equals on the calculator and plug that in. What shape is this going to make? If the x is squared, it's going to be a u. So let's see what happens with this u, though, and see if y'all can guess why. So I'm going to go back to y equals and clear it out. Now, remember, these are 2 different buttons, right? That's your negative button. That's your minus button. Negative x squared minus 7. The negative button's below the 3. Then hit your x. And then your x squared button. So negative x squared, and then you want to type in minus 7. Let's see if it gives us a u like we do. Thought it does. What is the u, though? What happened to it? Upside down. What do you think made that u flip upside down? That right there. That's exactly right. That's what flipped it upside down. Okay? Not really concerned with that right now. We're going to get way into that when we get into quad functions. We're going to learn everything about every characteristic about them and why they move where they move. Okay? But right now, I just need to figure out this chart. Forgot to look. I think it's negative 2, negative 1, 0, 1, and 2. So what's going to make that upside down U? Go to second graph again. There's your chart or your table. So negative 2 goes with negative 11. Negative 1 goes with negative 8. 0 goes with negative 7. 1 goes with negative 8. Remember, that right there is why what happens? The mirror, the U occurs because you have y's that are the same, which means they're in the same spot right there. So, and then what? 2, negative 11. So let's see, my first point is at negative 2, negative 11, which would mean to do what? Go left 2, down 11. And I only drew down to 11, so I'm just going to do it left 2, down 11. left 1, down 8. Left 1, down 8. 0, -7. Your x is 0, which means you're not going left or right at all, right? You're just going to go straight down to -7. 1, -8. So again, my y's are the same. That's where the mirror is, right? So 1, -8. To the right 1 and down 8. And right 2, down 11. So just like we saw in the calculator, there is an upside down graph of a U in that area. Okay, the next graph does have a different shape because it's x cubed plus 9. So the x isn't being squared anymore, it's being cubed. That gives it a different shape. So go back to y equals and clear it. So typing in x to the 3rd power. So you'll go ahead and hit your x button. And nobody has its own special exponent key except for x squared. Okay, every other exponent that you're going to type in, you're going to hit this little, I don't know what the name of that is. It's like an up arrow, but not this up arrow. Is that called a caret? Caret. Caret. Okay, so hit this caret button. That puts your cursor up in the exponent, and then you just type in whatever your exponent is, which is 3. Another thing that occurs when you hit that caret button and you put the 3 up there, my cursor is still in the exponent, right? I need to type in plus 9, but I do not want that in the exponent. Okay, so make sure before you hit that plus 9, you hit this right arrow right here. That puts your cursor back down in the regular area. Then hit your plus 9. So let's see what shape this gives. So graph it. Okay, and it's hard to tell, but look, it's going to go up here, and then it does a little juke right there at the top, and then it continues going this way. If you are an x cubed graph, it's going to have that shape. That's what x cubed graphs look like. Okay, probably, unless you're calculating, unless you've messed with the window, the highest number that your y goes to is probably +10. So that's why you can't see that part after it does on your calculator, right? If you're at the standard window, okay? And we'll do window manipulation and all that later on. But for now, all we need is that standard, okay? So it's going to have this squiggle shape. So when you're graphing in MATLAB, remember, you're going to have to tell it that. You go over there, and when you hover over the shape that looks like this in MATLAB, it'll tell you cubic tool, right? Which is what it is, the cube graph. So now that I know what shape it's going to be, I want to see the table. So second graph, there's all the points that you need. So -2 goes with 1, -1 goes with 8, 0 goes with 9, 2 goes, oh, excuse me, 1 goes with 10, and 2 goes with 17. So let's see. -2, 1. Left 2. Up.
Up. Left 2. Up.
-1, 8. Left 1. Up 8. Left 1. Up 8. 0, 9. No left or right at all. Just go up to 9. So that's where that little juke is happening, or starting to happen. 1, 10 would mean to the right 1 and up 10. So see what's happening? That's where that juke is happening. Then at 2, 17. Our graph in the standard window didn't go up to 17, but where would that be? So over 2 and then up here somewhere, right? To positive 17. So if I connected, there is that cubic shape. Okay?
Mine looks different, but okay.
Okay, the rest of these problems, 15 through the end, I'm going to actually draw all of these separate graphs all on the board at once. It's 4 different graphs. The question on each of these graphs is all the same. It's just asking you, is this a function or not? Okay, now remember, the definition of a function is any relationship where the domain values only correspond to one y value or range value, right? We talked about that on Monday. That was like the literal worded out definition. It's actually much easier to tell if a function, if a relationship is a function, if you see its graph. And the reason is you use what is called a vertical line test. Okay, so I'm going to draw 15, 16, 17, and 18. I'm actually not even going to draw the x and y axis because the only thing that really matters is the shape of the graph. So 15 looks like this. 16 is a oval. 17 is shaped like that, and 18 is like that. Okay, so what it wants me to do is for each one of these wants me to determine whether or not that graph or that relationship is a function. What the vertical line test says is, remember the vertical line is this one, right? The one that goes straight up and down. Horizontal, vertical. Okay, so what it says is if you draw a vertical line through your graph and touch it, and it touches your graph more than once, it is not a function. That would mean if I translated that graph into words, I would have values in the domain that went to different values in the range. All you need to do is the vertical line test. Look at number 16. I'm going to draw vertical lines all over it. Is there anywhere on that green check where any of those vertical lines touched it more than once? No. That means it is a function, right? This vertical line only touches it once. This vertical line only touches it once. There's not a vertical line that you can put on there and touch it more than once. That means, yes, it is a function. What about this one? If I draw a vertical line right here, how many times did that vertical, semi-vertical line touch the shape? It touched it twice. Any number more than once means not a function. And you know what's so funny to me? There's a problem like this on the final. It's one of your problems. It actually ends up being one of the most missed questions, and I cannot for the life of me figure out why. I think the people just get it backwards or mixed up or whatever. But there is a vertical line problem on your final exam. It is one of the 25 questions. There's only 25, and that's one of them. I can't remember if it is a function or not. Can't remember what the shape is, but it's a vertical line test problem. What about this one? Is this a function? How many times did it touch it? Touched it twice, not a function. What about this? How many times did that touch it? Once. How many times did that touch it? Once. 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 I can't put a vertical line anywhere on there that will touch it more than once. So is this one a function? Yes, that one is a function. Okay, so that wraps up 2.2. So we are going to get as far through 2.3 as we can. 2.3 is talking about domain and range. So remember, what is domain talking about? All the x values of the function. Or in other words, how far left and right is covered by your graph, right? Because that's what x tells you, how far to go left and right. Your range is your y values. Y values. Or if it's a continuous graph, your y values tell you how far up and down your graph goes, right? That's what y values tell you, how far to go up. Or if it's negative, how far to go down. So let's look at the first one, okay? And I'm going to free draw this. Try to as best as I can. Okay, give me a second. I'll bring it 2.3. So there's just a bunch of random points on this one. All right, so those are all those random points that are on number one. It wants me to do 4 things. It's like it's 4 problems in one. The 4 things we're going to do is find f of -2, we're going to find the domain, all of the x values when f of x equals 4. And then we're going to find the range. So those 4 things. Okay, now, this first part of the problem says find f of -2. If there's a number in the parentheses by the f, that is an x value. Instead of saying f of x, it says f of -2, which means this is the x. So that means what is happening in this picture when x is negative 2. So let's think about this. Here's where x is negative 2, right? Which means, what does x being negative 2 mean that the point has done? What does x being negative 2 tell you to do? Go left 2. So anywhere has gone left 2. Wouldn't anything along that real faint line, look at that line, isn't the whole thing to the left 2? Everywhere on it is to the left 2. Which point are they talking about then? This is the point where the x would be negative 2, isn't it? That's the only point I can see that has gone to the left 2. This one has gone to the left 1. That one's gone to the left 3, left 4, and other stuff. This is the only point where the x coordinate of that point is negative 2. What's the y coordinate of that point? Where is, oh, mine doesn't line up very good, does it? What is the y coordinate of this point? What's its y? It's 4, which means f of negative 2 is 4. When x is negative 2, y is 4. Is there anywhere else where x would be negative 2? If there was, you would see it lining up with this negative 2 on the x-axis. There's not any other points that line up with that negative 2. There's no other points that have gone to the left 2. Now, the second part of this wants me to find the domain. What does the domain stand for? What does that mean? Your x values, right? Which means, since this is not a continuous graph, it's just boom, 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 separate points. It just wants to know what are the x's of all those points. So, starting over here, what is the x of this point? What x is it lined up with? If you have yours printed out, it's probably easier to look at it or brought up on your computer, right? Because mine's free drawn. If you have it printed out, you'll be able to see exact. So what is this x lined up? What is this x coordinate? Negative 4. So I'm done with that point. This point, what is its x coordinate? Negative 3. This one's x coordinate is negative 2. This one's x coordinate is negative 1. What's this one's x? 0. Good. This one's x. So now we're going right. So now it's going to be positive 1. And this one is positive 2. So 1, 2. So negative 4, negative 3, negative 2, negative 1, 0, 1, and 2 are all the x values of all of those points. That would be the domain. So if they're separate points like that, you are literally just going to each point and naming its x coordinate. The third part of this problem says, find the x values when f of x equals 4. Okay, f of x and y are the same thing. So if you want to think about that, this says find the x values when y is 4. F of x and y both mean function of x. So where is y 4? Let's think about that. Here's where y is positive 4, right? What does that mean? If your y coordinate is positive 4, where have you gone? Up 4. Let's think about where all that would be. This is up 4. So if I draw a line this way and this way, isn't any point on that line up 4? So there's actually more than one point that has a y4. This point has a y value of 4 because it's gone up 4. But this one's also gone up 4, hadn't it? It's lined up with the 4 on the y-axis also. So there are 2 points that have gone up 4 or have a y-coordinate of 4. So what are their x's? So I'm talking about these 2 points. Those are the ones that have gone up 4. What's this one's x? Negative 2. And this is the other one. What's its x? 0. So negative 2 and 0 are what's happening when y is 4. The range, separate points, which means I'm just going to go to each point and name its y coordinate. I'm actually going to have, some of them are going to have the same y coordinate, right? Like these two just did, right? Those y's were both 4. If you're repeating a number, you don't need to write it twice. You just write it once. Okay? So since I'm talking about range, I'm going to start with the lowest, because range means always up and down. So here's my lowest one. What is its y? 3. These both have the same y. They're both 4. These both have the same y. What are their y's? 5. And these other ones also have the same y's. What are they lined up with? 6. So 3, 4, 5, and 6. Those are all the y values that you see here. So that's how you do those problems if there are separate points. This next problem is a continuous graph, okay? So it's a little bit different. It's going to ask me the same 4 things. Probably just switch around some numbers. So let me draw. I'm going to free draw this one. And it is a continuous graph. I'm going to put the important spots. Yeah, I'm trying to. Okay, so I'm drawing it to hopefully be good with the points that I need, because the first thing I'm going to need to find, let me write down what else it's going to have me find. F of 2, the domain. X values when f of x equals 3. And the range. All right, so first thing, if a number is inside these parentheses next to the f, what's that number representing? X. So I need to go and find where x is 2, which is right here. What does x being 2 mean? You've gone to the right 2, right? So anywhere I've gone to the right 2 would be right here, right? If you are on this line right here, this is just an invisible line that I drew up there so we can see where I went to the right 2. That means it's that point right there, right? That's the only point that's right 2 on that graph. What is the y that goes with that? 3, right? Right 2, up 3, gets me there. So f of 2 equals 3. Domain. What does domain mean? X values. Now, this one's not separate points. I can't just go to separate points on here and start naming X coordinate. This is a continuous graph. So now what we need to think about is how much of the x-axis is covered in this representation. What do these arrows mean right here? What is happening here? Does it just stop there? No. That means it goes forever. This arrow means it's going to go, we're talking left and right, right? That's domain. X values is left and right. This means it's going to the left forever. This means it's going where? Right forever. Well, if you're going to the left forever and to the right forever, aren't you going to cover the whole x-axis? Is there any part of the x that's not going to be covered? No. If there was, then you would see a stopping point. It wouldn't go right and left forever. Okay? I'll show you one like that in just a second. So this right here, when you're talking domain, it's got a multiple choice situation. Left and right forever just means it's going to cover all real numbers. The domain is I think it'll be easier to see when you see a situation where it doesn't cover everything, like when we do the range here in a second. The next part of this, what are the x values when y equals 3? Well, where is y3? Let's think about where y3 would be. That means y being 3 means you've done what? You've gone up 3. So here's y3, anywhere here, right? Everywhere there. If you're a point on that invisible line I just drew, that means you have gone up 3, which means what? Your y is 3. So looking at the graph, where does that occur on that green V? It occurs here and here, right? 2 spots have y3 coordinates. What are the x's that go with those points? What's this one's x? 2, somebody just said it. And what's this one's x? 8. So 2 and 8 are the x's that go with the y's being 3. Now, the range. Okay, I think this will help you understand when the domain or range is all real numbers or not. Because the range is not all real numbers. What do the range tell you? What's range? Your y's, right? Or in other words, how far up or down does this graph go? This graph has a bottom. There is a point on this graph where there is no shape below it. This point right here, right? Does your graph, does that V ever go below that point? No. It is only above or greater than that point. So what I need to know is what is the y value of this point? What is it lined up with on the y? It's lined up with 0. So the smallest y you are ever going to see on this picture is 0. Where is y -1? It's right here, right? Well, look. Is there anything where y would be -1? No, because it stops at 0 and doesn't go below it. So your range is going to be, doesn't it give you some kind of multiple choice situation? Yeah. So it gives you 5 things. Y is greater than, y is less than or equal to, then a y is in between kind of situation, and then y is greater than or equal to. So be careful here, choosing between those two. Because is there a point, this symbol right here, when it has that equal to bar, that means greater than or equal to. That means it's going to touch that number. So it's going to be 0, right? Does it touch 0? Is there a point on this graph where the y is 0? Yeah, this point right here, y is 0. So it is greater than or equal to 0 is the range. Okay? Go ahead. No. And the reason is, here's where -1 is. There's actually numbers in between there, right? So, because there's numbers in between there. They're just not whole numbers. Yeah. That's a good question. All right. Y'all actually can go a little bit further. Number 3, 4, 5, 6, 7, and 8. Oh, good. The rest of these are all the same kind of problem. It's asking for the domain, but it doesn't give you a picture. It gives you like the drawn out wording of the function and asks for its domain. Now, for the most part, what you're looking for when you're trying to find the domain, which is your x values, you're actually going to kind of try to find what x could not be. Because once you find out what x cannot be, then it can be everything else. Here's why I'm saying that. On number 3, it says find the domain, and you've got f of x equals 6 over x plus 14. So here's what you're looking at. Here's where my x is in the function. I'm going to have a restriction on this because x is in the denominator of a fraction. There is a certain number that you cannot divide by. What do you think it is? What can you not divide by? What cannot be the denominator of a fraction that makes it called undefined? 0. So that means what if you have an x in the denominator of your fraction, it can be anything except what's going to make that denominator 0. So what you need to do is just say, I don't care about the top. This right here, x plus 14 cannot equal 0. If it equals 0, that fraction will be undefined. So then just set that up and then just solve it like you would a regular equation, which means get x by itself by subtracting that 14 from both sides. So x cannot equal -14, right? Because if you were plugging in numbers for x to try to find points to plot and you put a -14 in for this x right here, what's going to happen? You'd have -14 plus 14 in your denominator, which is 0. And then you're going to be stuck because you can't plot that. Because when you do 6 divided by 0, you're going to get an error in your calculator because you can't divide by 0. Okay, I forgot. Let me look at this and see how it. Oh yeah, so it's multiple choice. X is a real number and x cannot equal -14. It can equal 0. Do you see how one of the answers says x cannot equal 0? X can be 0. You can put a 0 right here. Because if you put a 0 right there, you're just going to be left with 6 equals 0 plus 14, which is fine. Right? It just can't be -14 because that's what makes the whole denominator 0. Okay? All right. These next problems, I'm going to go ahead and knock it out because these next ones, 4, 5, 6, 7, and 8, what you're looking for is a restriction. You're looking for x's in the denominator. That next one, your problem is f of x equals 2x minus 5. Look where this x is. If you're making an XY chart and you're plugging in numbers for x, what would you have to do to any number that you plugged in there? Multiply it times 2 and then subtract 5 from it. There is not a number in this world that you can't do those things to. You can multiply any number by 2. There's no restrictions on that, right? And you can subtract 5 from any number. It doesn't matter if it's a decimal, negative, rational, irrational. You can subtract 5 from it. So this one would be x is a real number. It can be anything. X is a real number. Next one. Number 5. Your function is x squared plus 2. Essentially, what you're looking for on these is an x in the denominator to create a restriction. Can I put anything in here? Can you multiply anything times itself and then add 2 to it? Yeah. X is a real number. Again, once you get to 6, you've got g of x equals 9 over 6 minus 5x. Here's where I see a concern. I've got an x in my denominator, which just means I need to say, okay, well, 6 minus 5x cannot equal 0, and then solve it to see what x cannot equal. So if I'm getting this x by itself, I need to get rid of this 6 first. I need to subtract the 6. Get rid of that positive 6. So now I've got negative 5x cannot equal negative 6. And then divide it by negative 5. So x cannot equal that negative over a negative turns that into positive 6/5. So x is a real number. It just can't equal 6/5. And that last one, all that it has is something new. It's an absolute value. Actually, 7 and 8 are both going to have the same answer, right? On number 7, you have absolute value of x minus 4. You can put anything in for this x. It can be positive, it can be negative, it can be 0, it can be a fraction, it can be a decimal, it can be anything. X is a real number. And then the last one, it's x cubed something. Minus 9, thank you. So here's where you'd be plugging in for x. What would you be doing to anything you put in this spot? Multiplying it by itself 3 times. You can do that to any number. X is a real number. So on that part of the problem, so we finished 2.3. I'm so excited. So all we have Friday is 2.4. So what will we do this Sunday will be 2.2, 2.3, 2.4. Right now it says 9.1 and 9.2. Those are bumping to next week. So this Sunday is 2.2, 2.3, 2.4. And we'll do 2.4 on Friday. Oh, hang on, I left my, hang on. All right, Cole, I got you. Kavion, Macaulay, and Davis. Okay, y'all are good.